Hello. There is no stream this Saturday because I'm outside of Warsaw, so I don't have my PC near me, but I'm pre-recording this earlier in order to premiere this on Saturday just so you can watch it just like if it was a stream. I will try to hang out in the chat. Yep, in 10 seconds I will do the Codeforces round by 3 authors including Steph Daska. Yeah, I can make some drawings for you and it will be just virtual participation. I don't know anything about the problems. Smallest possible value of this. So for every bit, if possible, XOR both things. Should I just print XOR of A and B? That's interesting. Oh, I didn't clear stuff. I will explain more with next problems. Not here. With Codeforces system, scoring system, you can't really spend a lot of time on the first one. So this one I will just submit, and starting from the next one I will do some more explanations. Here it was just about understanding what happens for every bit. If both are ones, then I can cancel them. I need to read again. We need to invert at most 2 cells between 0 and 1 so that it was possible for him to move no matter what the digits are. No. I'm kind of guessing the statement already, but my guess must be wrong. Oh, there's something. Damn it. I need to restart my tablet. This is a bad start. Okay, now should be good. Yeah, so my first understanding was that it's something like there is a grid, some values are 0, some are 1s, and you need to change at most 2 cells so that it was possible to go from F to S only using 1 digit, but that's some bullshit, because if half of a grid is 1s and half of a grid is 0s, then what do you do? To only go to cells values in which are equal to the digit he chose. Oh, they want him not to be able to do his traversal. They will invert at most 2 cells. I see. I see. Maybe it's enough to focus on those 4 digits, and it's at least 3. Okay. If it's this situation 1100, then it's impossible for him to do a walk, no matter what is between. We can forget about all those digits in between. If this is the input, we don't need to change anything. Right, then if this is, if I can with 2 operations make this, I'm good. Is it always possible? If something is 1, 1, then I will change the opposite 2 to zeros. And if this is 1, 0 and this is 1, 0, I can change it like that. This and this. Okay. Should be good. This is BCPP. Read, and now change those 2 to 1s, those 2 to zeros, or the other way around. What about that? A of 0, 1 plus A of 1, 0 plus the opposite of A of -2 and -1. Will this work? This is cost needed to get a situation with 0, 0, 0, 1. Like if this is 1, then I have a cost of 1. And now if this cost doesn't exceed 2, then I do that. And I print else. I don't even want to check because I assume this is correct. Short copy paste. Doesn't hurt that much. And print the grid. Oh, okay, I messed up. We need to print coordinates of changed cells. So, what goes first, row or column? Damn it, only zeros. Okay, this is first 3, 4. Okay, this is 3, 4. So row goes first. I don't know why it isn't set, unless I'm missing it from the statement. Those are changed cells. Repeat twice. I want this to be equal to rep. and the opposite of rep, the other side. Done. And I have numbering from 0 to n-1. So we need to add 1 while printing. I could add some assert. Okay. Well, submitting doesn't hurt too much because there is no penalty for wrong answer on sample test. I could put some assert for what happens if neither time I find this something of size at most 2. Wrong answer. This question mark, I think I shouldn't look at that anyway because during a contest I wouldn't see it. Okay. Oh, I always just print this. Yeah, that's completely wrong. I'm reading the input wrong. Those are... Damn it, those are strings. I don't think I'm going to win this round. Is my solution correct at all? I try to get 2 1s here and 2 0s here, or the other way around. If I achieve that, there is no path for him. If it's 0 0 at the top or 1 1, then I will manage to do it. If it's 0 1 here and 0 1 there, then I need to change to it. It seems fine, but let's put an assert. And let's add some more tests. It didn't fail. It did fail. 1 1 0 1. And it fails for this. For repetition equal to this and that. I should create it here. I repeated something twice and sadly I remembered vector from the first time. That will hurt in the standings. Good that I'm not rated for Division 2. Change string into a palindrome by doing what? For example, suppose this append CB, this like that. Okay. Okay. Like for that, I can, for example, choose to append this. Then I will get EDCB, if I understand correctly. Make it a palindrome at most 30 times. Why? And I cannot, if I could be n, or I here could be 1, then I could just take this whole thing, append it reversed, and I would have a palindrome. Okay, let's try to figure this out for some short string without any repetitions. If I do it for string without repetitions, it will also work for any string with repetitions. Let's just do ABC. I can put B here. B. This is a starting string. Put B. I could put here C or CB. Doesn't help as long as there is A here. What can I do on the left? Put B. Possibly also C if I want. Okay. Put C here and then B. Like that. Does it work in general? Have this. No, D, C, B, A, let's say. No, I cannot put A. At most this. And here B, C, D. Let's say that this will be the middle of everything. I can put here B and C if I want, but I cannot get D. How do I get D? Unless I put this to the front, to the end, but then I'm lacking C. Would it help to have two equal characters in a row? Maybe I should have like two steps. Just DD. If this is the case, then I can easily just copy this to the end. And I have a palindrome. No, I cannot. For that, I can copy you. Maybe 3 characters in a row. B, C, DD, and after DD I can copy another D. Yeah, that's good. If I get 3 characters in a row at the end, I should be fine. There is whatever, d, copy this, so it's reverse of whatever, and then d. And then looking at from here, I copy you. How to get 3 equal characters in a row. Or maybe it's impossible. CB, C, it's impossible, right? Damn it. Yeah, here it's not that I did this. Never mind then. I can write a brute force to tell me what I should do. If it tells me a sequence of operations for A, B, C, D, E, I think I'm good. But maybe let's try to use this one. A, B, C. B copied to the end. And B, C copied here. And because B was so nearby, I copied it here. Let's think about directions here. B is pointed to the right. This one is reversed. This one is reversed, so this one is like this. And this is why if B was more than one character, this wouldn't be a palindrome. Or would it? CB, BC, BCD. And then it would be nice to copy this again. CB. Is this a palindrome? Was it that easy? That's the initial string. The order of operations is 1. And then 2. And 3. So the white one here is 3. Is it? Hey, it is a palindrome. What do we do? So we read. Actually, I will just use length of that string. Li. I assume that n denotes the current length. Reverse to the front. L represents the first operation. So first was the green one, it's to the end, so this is R. Then blue one was second, this is L, and the white one was third, this is L. The first one is just that. Do we always copy the same length? We copy BC, then BC, then BCD. Maybe this will be enough. First was R. Yeah, first was R. R is second operation. Obvious strategy, submit in hope that this is fine. Is from this to that. -1. Oh, this reverse to the end, I should print here 2. Because it's from 2 onwards. This is up to that. Try number 2. Nope. And try number 3. I also need to print the number of operations. Do I have a bad day or what? Here. This. Apply R2 from ith index to n-1. So this append reverse to the end. AB. Then my program prints L3. What does it mean? This reverse to the beginning. So B, no, this is AB and then everything. Where will C be? Oh, I also want U. One more submit, but I don't believe in my code anymore. No, accepted. What place do I have? Oh, that's not... That's ICPC style. I didn't realize that. I think strategy is the same. Hexagons. There are costs for each direction. Print the smallest cost of a path from the origin to the given cell. Maybe going to the right is very costly, and then we need to use C1 or C3. Is it true that we will use only 2 types of operations? Or maybe 3? 2 would be nice. Can it happen that we use 3? How do I want to do it? Save image as. Sure. No, that's how it works. I want a. What is this? Now I cannot increase it. Fine. If I want to go from start to the end, maybe with red, from here to there, I have some possibilities like right down or far right and then bottom left, and so on and so on. Does it make any sense to move in that completely different direction? I don't see how it helps, or this one. How do I combine those things? Does it make sense to move like that? Let's prove that it isn't good. If this is optimal, this is optimal, then apparently this is better than doing that. So going twice to the right is better, or just simply going from this to this is better than going like that. But then I could as well go just to the right, because instead of going up right and bottom right, I go to 1 times extra to the right. Yeah, so in this case I don't need to use 3 different directions. Then I will assume that 2 are enough. Then I need to figure out formulas. What is the numbering? This increases just to the right. Then this increases by +1, +1. And this increases by just 1, 0. Yep. So to the right it's +1 for the second coordinate. This is +1 for first coordinate. And this is +1, +1. And I can mix them. So it's trivial to mix those two. How will I mix those? Like, I don't want to implement a lot of, if there are 6 directions and I consider every pair, that's 6, choose 2 pairs. It's quite a lot. I don't want to have that many ifs. maybe 3 possibilities are enough to just say that there are 3 directions. And yeah, maybe. Okay, I will say that there are 3 directions. There's red direction, light blue, and green. If I want to get over here, I will just combine 2 of them. I might want to use binary search or like ternary search. Okay. Quick look at input format. Test cases, X, Y, and the 6 costs. In this order. Long longs are necessary, so why won't I use it here already? Okay. Now I will have 3 parts of my code. The easiest should be to combine red with blue. Because red goes by red green is easiest. Because one goes by +1 to the right, this one goes yeah. So it's exactly answer is I can call it red green. It will be what? How much I need to go with red? This is the second coordinate, y, times some cost plus x times some other cost. But it isn't that simple. Green cost, if x is positive, then with green cost I need to take some value, otherwise some value. Let's create a function. Green cost. Let's call it A. If this, so if we go up, then C6. I think this will be more convenient to use the same numbering as they did. From 1 to 6. Return minus A times C3. Red cost is the same, but to the right it's C2, to the left C5. And finally, blue cost is C1 and C4. This could be maybe automated like instead of copy paste, but it isn't that bad in my opinion. So this is green cost of x plus red cost of y. Then the more complicated stuff. Let's go with red blue. Red, there will be some formula. Oh, blue must be only blue here modifies the first coordinate, and then red I unnecessarily moved by that much, so this right? Like for example, if it's 3, 5, then 3 times I will move with blue and twice I will move with red. Finally, green, blue. Print the minimum of 3 values. If something doesn't work, then I will print them one by one, just to see what's going on. It works. Let's submit the nice. And the last problem, Swedish heroes. 4 accepted submissions so far. Pick 2 consecutive heroes and change them into the sum multiplied by -1. Maximize the final power. Maybe we need some smart interpretation of this. When you combine 2 things into one, you can think about it as a binary tree. There is A1, A2, A3, A4, A5. Then they are combined like this. This would mean that A2 and A3 are combined, so then we have the sum of them with minus. Every number will be counted with some multiplier here in the final answer. Whenever we go up by 1, your value is multiplied by 1. So for every element, I can count how many times it was merged with something, and if it's odd number of times, it's finally with minus. In this case, A1 would be with plus, like A1 would be added to the answer because it was multiplied by -1 and then multiplied again. Then this is with minus, minus, plus and plus. Perfectly, I would choose this sequence of pluses and minuses just to say that every number becomes positive. But it might be impossible. It is apparently possible here, because the sum of all numbers is 26. If I wanted to do everything perfectly here, it would be 18 plus 2 plus 1, it's 21. But it isn't. Maybe there must be some properties satisfied. Maybe for odd n, I can always make everything with plus. Or for divisibility by 4. Well, for 4 I can do this. For 5 maybe for 5 2 elements need to be taken with minus. Oh no, wait. It's not that. It might matter what are the initial signs. The question is just, okay, another question. Is the order of pluses and minuses important? If I can achieve this sequence, is there also such a tree that this sequence is achieved? So could I sort the numbers in the input? This is problem E. If something is minus, I could just assume that it's a leaf, and then let's take care of the rest of everything. Can I create this exact sequence? A1 will be just once, where I want to here have A2. It will be twice. A3. A4, A5. Does this work? Can I get minus minus plus plus plus? I don't know why I'm typing A1, A2, and so on. Just let's say 1, 2, 3, 4, 5. Does that work? It does. I need a nice interpretation of this. How can I interpret a tree, a binary tree, for example, as a sequence of moves down and up? $15 already, but if some people solve this problem, several more minutes and I should be good here. What about this? To try to get accepted quickly, I will guess that this lemma is correct, that the order doesn't matter, and it's just the number of pluses and minuses. And let's investigate different values modulo 4, something like that. If n is 4, or if n is 2, then that's the only possibility, that 1 and 2 are connected into a single vertex, so it's minus minus. If n is 3, I can do this. Oh, actually I have just two possibilities. Either this or that. So the middle one must be plus. What are the stats? Okay, this is not an easy problem. Plus, plus, minus. I cannot do anything else, can I? Actually, the statement didn't say about segment tree. What did it say? Take two consecutive things and multiply each of them by -1. Should I write down possibilities for n equal to 4? Perfect binary tree, then it's plus, 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 plus. This is minus, plus, minus, minus. And, well, a few more. Two and 3 and a 4. This is minus, 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 plus. Basically, with one and on the left, it's minus, and then one of those flipped. This corresponds to that, because this drawing is the same with this drawing. This drawing is the same with this drawing. And there are possibilities where one isn't just a leaf on the left, the only left child of fruit. What else is possible? 1, 2, I already considered that. No, but that's not the only possibility. Now there can be 3 and there can be 4. This would give me minus, minus, plus, minus, and also one, 2, 3, 4. This is plus, minus, minus, minus. Total either all pluses or a single plus. But I already saw for n equal to 3 that it's not that the order doesn't matter. What I can do is, I can write a brute force. Write a brute force and then see what sequences of pluses and minuses are possible for every next n. Maybe for bigger n it's easier. N equal to 4 can be described by either all pluses or a single plus. This cannot be any dp because n is too big. Well, let's try to write a brute force to give us some information. It's exponential. How can I do it? Let's say that let's create a set. Let's say that you return a set of strings. Can I do this? I can. Otherwise, iterate over split point and say that we have two intervals, two subtrees. Iterate over left size. For example, if n is 5, maybe the left child of a root is of size 2, like the subtree, and then right is 3. Now I consider all the possibilities. For every string s1 in A, for every string s2 in B, create a new total string. This is s1 plus n2 plus s2, but everything is flipped. Like that. This corresponds to plus and minus, whatever. Insert. I could add memoization, but whatever. Not all, this is expo. This is possible for n equal to 3. That's just, yeah, let's go with plus and minus. And to match my drawing, the middle is plus. Does it match? Yes, it does. For n equal to 5, do I just have here all possibilities for two minuses? 5 choose 2, it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there a single impossible thing? It would need to be symmetrical. Second and fourth. Yeah, apparently I cannot get plus minus plus minus plus. What's the count of them? 5, 10, 21. I don't recognize this sequence. 42, 85. Okay, it's always times 2 and plus 1 every second time. 25, 10, 21, 32, 85. I'm hoping for some insight. Nth number without consecutive equal binary digits. This is always roughly 1/4 of all possibilities. $128, yeah, this is 128 divided by 4. 64 divided by 4. So once every 4 possibilities is bad. Something modulo 4 must hold true. There might be an easy condition. This condition will talk about maybe just 2 bits or the sum of values, something like that. Then modulo 4 it must be something, and only then this is a good string. Are there strong people in the standings who hasn't solved it yet? There are such red people. Should I print zeros and ones? This does not contain minuses on 2nd and 4th position. This is 1 and 4. Maybe I need to care about the fact whether 2 consecutive characters are equal. If yes, maybe I can assume that they are on the same level. I want to understand what sequences of pluses and minuses are possible in order to know by what I can multiply those values. This tells me that those are possible sequences with which I take the values from the input. For example, I can take 1st plus 2nd plus 3rd value minus 4th minus 5th. Possible answer is 4 minus 5 plus 9 minus 2 minus 1. For 7 again, everything is possible. For 6 there are 5 pluses. Okay, but isn't every... Now I got an idea. I know that the sum of all binomial coefficients, n choose 0, n choose 2, n choose 3, and so on. No, sorry, every second. This is equal to 2 to n minus 1. Maybe this is around 2 to n minus 2. So maybe here we say there are not. I will write down what is possible number of pluses and number of minuses. I will count frequencies of them in a map. Two occurs 15 times, 5 occurs 6 times. Let's do this. Okay, what is 4 pluses occur that many times? Is this just 10 choose 4? Yes. What about 10 choose 7? 120. 10 choose 1 is this, 10 choose 1 is this. So for 10, it just the number of pluses must be 1, 4, 7, or 10, no matter the order. For 9, $36. Here 1 is impossible, and then 9 choose 8 is obviously 9. The one I marked, it should be 126. Maybe just plus minus is bad. Okay, 8 choose 0 is 1, 8 choose 3, 8, 7, 6 divided by 6, 8 times 7, yeah, that's exactly this. 8 choose 6 is 8 choose 2, that's 8 times 7 divided by 28. 7 choose 4 is 7 choose, well, let's use internet. 35. So also here one thing is impossible, but this is a pattern. Here, here, and there one thing is impossible because we cannot go with plus minus plus minus plus minus plus minus plus. Other than that, everything is regular. And this also explains why this was impossible for n equal to 3, right? In our drawings, plus minus plus is an exception to this rule. Other than that, any two positions are good. Okay, then to understand better, let's just put counts here. Let's print it. So n model of 3 is important, apparently. For 8 it's this, the number of pluses modulo n, like for 8 it's 0, then 2, then 1. So for example, I can say that the number of pluses plus the number of n's plus 1 must be divisible by 3. Well, now can I implement this? I will write down what I know. So if I have n modulo 3, then this 3 minus that, necessary and sufficient conditions for a sequence of plus minus to be possible. And modulo 3 count pluses plus 1 modulo 3 is 0, right? Like this. Yep, this is 1. The string isn't for odd n. This is forbidden. This gives me a dp, because it will be just dp on what's the current position, what's the divisibility by 3, so remainder modulo 3 of the number of pluses taken, and whether we still follow this pattern, whether we always have just plus minus. At the end, I don't want this to be true for odd n, and this plus n plus 1 modulo 3 must be 0. That's the most bizarre and non-understandable solution I came up with recently. I bet that editorial is completely different. Yeah, let's do this. If authors of this round later watch my video, I wonder how they feel about this. I don't know. It's like when you create some product, some website, and then you expect your users to behave in some way, but then they do completely the opposite. Or maybe the editorial that will describe exactly the same thing. Read this, and now it's dp of max n, 3, and 2. This should be defined as maximum sum of values so far. So I initially put everything as minus infinity. Remainder and the pattern thing. No, I don't want to write it with Boolean value smaller than 2. No, not true, 0. Okay, now go through that. I cannot type. Pattern is a Boolean value, whether the pattern plus minus so far is true. And by default it is true. At the end I don't want this to be true. Actually, let's put it like that. If n is odd, then put this value to be true, and I want at the end this to be false. At the end I will need dp of n something 0. How can I do this? 5 minus n modulo 3. Five minus 0 is 2. 5 minus 5 is 0. Okay. Yep. Consider taking this number or not taking this number. Let's say first taking this number. And now this is something dp of I rem pattern plus a of I. This is take. This is not take. I mean take with minus. This is plus minus. I need to figure out whether the pattern still holds. For I equal to 0, if I'm putting a plus here, so like that, then pattern holds. Here, pattern doesn't hold. No, it depends on I modulo 2. So pattern holds if and only if it held so far, and this is even. Max self not declared. I very much don't want to get wrong answer on non-samples. Let's create something where, oh, is this a counter test? If plus minus was possible here, yeah, if plus minus was possible here, then the answer would be big, but it isn't. Then it's very nice of them to give such a counter example. I'm saying 75% that this works. My DP can be wrong, or my whole idea can be wrong. Why doesn't this work for n equal to 1? 5 minus 1 modulo 3, this is 1. The pattern is allowed for n equal to 1. So now let's say 70% that this works, because on one hand I figured out something wrong, so now it's better. On the other, this could be not n equal to 1. That being said, accepted, cool. I'm not that far behind. Why is that? Maybe problem E indeed is very difficult. I'm very curious what the editorial says. And obviously I was quite slow. Eknerwala solved everything in 20 minutes. So D, we have the same time. Yeah, D, fine. But ABC, it's just B and C. He solved them in 4 and 5 minutes. It took me 12 and 15. So let's investigate a little bit. Why was that? In B, okay, I kept getting some wrong answers. My first submission was 9 minutes, and I couldn't understand the statement. Plus, I needed to fix my drawing tablet. So this is understandable. What about C? Okay, for C, I spent way too much time. I don't know how. Maybe I thought it's more difficult. But now, also in a few minutes, somebody can still beat me because I have 2 wrong submissions. And I believe the final time is your sum of submission times. So the 1 plus 13, 28, 40, and 79. Let me check that. This, yeah, plus twice the 20 minutes for every wrong attempt. So for the next, a lot of minutes, actually, not just a few minutes, people can still get above me. For example, if this guy now submits, for sure he will be better. But I should be top 10, let's say. Oh, okay, not top 10. I'm already 9th. Let's find editorial and read it for E. This is this round. There are video solutions too. Hint. Sneaky corner case. And it's okay. So it is exactly the same. So the solution now simply requires us to sort the array, multiply by -1 each number 1 by 1, and when this, update the answer with the current sum. DP can be avoided, but I thought that DP is the best way because there is the forbidden pattern. I didn't know how to forbid the pattern without DP. If not the forbidden pattern, then yes, I would also sort stuff. Okay, I think I know how to do it without DP. Proof by induction. Something like this one reversed, we always have that. I want to read this carefully. Suppose your solution looks like this. Split into 2 substrings such that their negation is achievable. Is this a forbidden case? This is n equal to 8, count is 3. This is allowed case. You can split into that. We can always find such a split. Start at the leftmost point and see if you can split into this. You can't. Splitting into that. The very first time the last two signs are equal is a time where we can make the split. If the left substring starts with a plus, the last two signs are equal. If this is plus, then there is some, it alternates. Then they say when there are two equal in a row, then we make a split. Wait, what? Before that, maybe. Yeah, after that. This and that. There is plus minus on the left, so it's like why this satisfies anything modulo 3? N is 6 plus 4. Yeah, so why is this good? If the left substring starts with a plus, the very first time the last two signs are equal is a time where we can make the split. Oh, but we flip. We flip. After flipping, this will be plus and plus. So it will be n equal to 6, and the number of pluses is 2. If I... Okay, this makes sense because we want the length of the left part plus the number of minuses to be plus 1 to be divisible by 3. It's 3 times some k, and this is true for something like that. It turns out 4 plus 1 plus 1 is divisible by 3, and if you add plus minus on the left, it's still true. If you add plus minus on the left, it's still true because you increase length by plus 2 and you increase the number of minuses by plus 1. The divisibility by 3 holds. Okay, I understand that we can analyze some stuff. Then also we need to analyze the minus. But is there some intuition for this? I will later check out the video by Steph as well. The video is here. I don't know. Okay, the recording is done. Let's quickly think what I think about the problems. I don't really like division to contests. Problems. Problem set. It was interesting observation, and also can be done with programming, so it's fine. B. Fine, easy problem. C. It's fine. The solution turns out to be very easy, but well, it's a division to contest. And I overcomplicated, or just I was stupid not to see the solution quickly. Hexagons. Even though it isn't bad, I personally didn't like it much. Maybe because I saw similar problems in the past, so there was nothing new here. I think I already knew the lemma about using only 2 directions. I will take a look at the tutorial in a moment. And E, I had fun solving E, but I could as well not solve it. My current place, still 9th, good. And yeah, what does editorial say about D? Perhaps we can prove only 2 edges are required. Perhaps. I would say that here it's very important what's the actual code. I'm proud of my code. I can take a look at somebody in the top. No. While I have virtual participation, I cannot open. I could maybe quit virtual participation, but I don't know, maybe I would disappear from the standings. Let's take a risk. Contests. I think this. Can't remove virtual contest because you have some actions in this contest. Maybe not. By taking this. C4 and C5 will never be used since they contribute in the wrong direction. I don't feel convinced. Oh, they are exactly on the opposite side. So if we are using those, okay, fine. We can now use those. If using C1 is not optional, we can choose C3 or C6. Without loss of generality, we can choose C3. Use all three. This means we use this. Okay, I get that proof. It's fine. Then it's not that I did something crazy. No, I guessed it. It's not that I proved it during a contest at all. I have no idea why this is true. Thank you, everybody, for watching this. As I said, if nothing changes, I'm going to put it on Saturday as a premiere, and hopefully I'm right now hanging out in the chat with you. Hope you enjoyed my struggling with problem D. That's the only, maybe that should be the most interesting part of this contest. Yep. See you on Tuesday on the Heart at Coder stream, which is also advertised on Codeforces main page. But there is some long discussion here about it, and most likely this will be shifted somewhere else because it's too divisible, and this annoys some people, and that's understandable. Actually, yeah, like, it's not that I always want to see here a long list of streams, especially if, if more people publish their streams here. So again, thanks for watching. Bye bye.